my choice. So please turn on your cam. For those who can turn on their cam, kindly turn on. And then please prepare your notebook, your textbook, your scientific calculator, and then your pen. So we are now in chapter 18, work and heat in a relationship. Okay, sana all in a relationship. Okay. Please proceed to Silid and download the module number 1. That will serve as your reference and guide for our activities and tasks for fourth quarter. The title is Q9 Psi A, Q4O, G9 Psi A, Q401, work and heat in a relationship. Okay, that is your first module for this quarter. Okay, so this will be our objectives for module number 1. Explain how heat transfer and energy transformation make heat engines work. To illustrate the parts of a heat engine, to solve problems related to work and heat, to elaborate on the different laws of thermodynamics, and to explain how the different types of power plants work. But for this afternoon, we'll just focus on solve problems related to work and heat because you're going to differentiate, okay, work and heat and what is the relationship, okay, before we will solve problems about it. Okay, for our first activity, we'll have the four picks one word. I think you're familiar with this. Are you familiar with four picks one word? This is very popular back then. I think when I was in college. Okay. So here's the instruction. So for this activity, you must identify what word related to chapter 18 is shown in the four pictures presented. So just type your answer in our public chat box, and the first person to get the correct answer will get 1,000 pesos. Okay, joke. Will gain 1 point in our activity later. Okay. So you have to give chance to others. Okay? Pag nagkuha na ninyo ang 1 point, ayun na mo pag-answer next. Give chance to others. Okay? So are you ready? 9H? Ready na? Ready na? Click the raise hand button if you are ready. Okay, very good. So let's have the first picture. Number 1. Okay. You have there the battery life. Person is eating chocolate. The baby is jumping, and then you have the solar panel. So what do you think is the answer? Okay, let me see. Let me see. First person to answer is Marinelle. Okay, let's see if energy is the correct answer. Answer reveal. Okay, very good. It's energy. Ako lang siyang gitambunan para dili makita. Anyways, energy is the answer. So, Marinelle, you get 1 point for our activity later. Okay, next. Number 2. What about this? Thermometer. And then, ay nag-barbecue. Nagipaningot. Ay nagpaypay. What is this? Okay, let me see. Okay, the answer is, okay, I think Isa is the first person to answer. Okay, the correct answer is heat. Okay, very good. Heat is the correct answer. So you will get 1 point. Congratulations. Next, for our third picture. Okay, what about this? Mm-hmm. Okay, Sophia. Okay, the correct answer here is, let's reveal. Okay, very good. Work. So you will get 1 point, additional 1 point for our activity later. Okay, so that's it. The three words. You have the energy, heat, and then work. Okay. So again, winners, we have Marinelle, Isa, and Sophia. Okay, congratulations and thank you for participating. Okay, let's proceed. Okay, please get your textbook and go to page 420. So, lesson 18.1. It's about heat and work. So, this will be our first topic for fourth quarter. So, first question, what is the difference between heat and work? I think you're familiar with work. So, let's start with work. Who can still remember in our previous quarter what is the definition of work? Yes, Miles?
Product of force and displacement.
Okay, so it is the a product of force and the displacement. So there is work done if there is change in position of the object. Okay, so that is work. Now, how about for heat? Do you have any idea? I think heat was discussed when you were in grade 7. I'm your teacher in your grade 7. So I hope that somebody from your class remembers or remembered what is the definition of heat. Anyone? Heat is okay, Lawrence.
Chair, ingon akong friend, chair nga, heat is a form of energy that is transferred between systems of objects with different temperatures.
Okay, so that is correct. In other words, when we say heat, that is the energy in transit. Okay. So let us now see the definition or the difference between work and heat. Okay, let's start with work. So just like what Miles said a while ago, when we say work, it is scientifically defined as the product of force exerted on an object and the displacement of the object in the same direction as the force. Okay, so this is the mathematical expression of work, force times displacement. And again, the unit of work is in Newton meter or joule. So 1 joule is equivalent to 1 Newton meter. So this is just a review about work. And now let's have the heat. Heat is the energy in transit. Okay. And the flow of the energy is from high temperature to low temperature. Okay. That is the natural way or natural process of the transfer of heat. So heat cannot be stored because we call that thermal energy. Okay. So it is transferred from an object at a higher temperature to a body at a lower temperature. So the process or the flow of heat will start from hot to cold. Okay. Never siya cold to hot. Okay? It will start from hot to cold. That is the natural way or natural process of heat in terms of its flow. Okay, from hot to cold, gina siya always. And this will be the equation, okay, or formula to solve for heat. Heat is represented by the variable capital Q. Okay. Other books, in your book, I think, gagamit siya H. But we'll just use capital Q. Okay. So, ayaw mo ka-confuse ha if H siya or Q. Kay parehara na siya. But the reason why I chose na or I decided to use Q, it's because you can use that in higher level. Okay? Di man sila gagamit og H. Q na ilang gagamiton, especially in college or in senior high. So Q is equal to M times specific heat, C. M is mass, C is specific heat, and delta temperature. T there is that temperature. It's not time ha or period. That is temperature. So final temperature minus initial temperature. Okay, since that is delta or change. And then the unit of heat is the same as work. So that is in joule. And then pwede siya in calories. Okay, or cal. And then kilocalories or kcal. So 1 kcal is equivalent to 1,000 calories. Okay, since kilo means 1,000. Okay, so later I'll just show the equivalence. Okay, so again, the unit of heat is in joules or calorie. Okay, depende kung unsang i-ask sa problem. Okay, so this is the formula, once again, of heat. And always remember that the flow of heat will start from high temperature to low temperature. Okay? If you can still remember in your grade 7, there are three forms of heat transfer. Okay, you have conduction, convection, and then the radiation. Okay? So once again, when we say Q, that is the amount of heat gained or lost by the body during heat transfer. And then we have M, that's the mass of the body. C is the specific heat. So later on, you will find out what is specific heat. And then delta T is the change in temperature. So pwede siya TF minus TI or T final minus T initial. Okay, for a while. Okay, so when we say specific heat, let me share the laser point. Okay. Specific heat, or represented by small letter C, this is the ability of the substance to absorb or release heat energy. Okay, there are different constant values, no, in terms of the specific heat, like specific heat of water, specific heat of aluminum. So kuha na siya constant. Don't worry, because that is somehow given in our problems later. But if ever you will solve for the specific heat, just use this equation. Actually, we derived it from the equation from the heat. Katong Q is equal to mc delta T. So C is equal to Q, or the heat, divided by mass times delta T. So you just use this equation if ever the specific heat is unknown. Okay. So this is the formula. And the unit for specific heat is in joule per kilogram Kelvin. Since Q is in joule, or the heat is in joule, and then mass is in kilogram, and the standard unit of temperature is in Kelvin. Okay, so K. But you can also use this unit for specific heat, calorie for heat, and then mass is in grams, and then delta T, it can be in degrees Celsius. So it will depend, no, kung unsang i-ask sa problem and what are the given in the problem. Okay? So that's it for the specific heat, the ability of the substance to absorb or release heat energy. Okay. Okay, there is a reversible relationship between heat and work. Okay? So it's like the concept of work energy theorem. If you can still remember, work done is just equal to the change in the energy, kinetic energy or potential energy of the object. Okay? Since heat is considered to be as an energy, right? So pwede na siya ma-reverse class. So it can be heat to work or work to heat. That is why we call that reversible process. Okay. So an understanding of the relationship between heat and work gradually emerged in the 18th and 19th century. So it was James Prescott Joule who discovered this, okay? Na ang heat can be reversed to work and then work to heat. Okay? James Prescott Joule, he is a British physicist and at the same time a brewer. Okay? He discovered in his experiment that the water, okay, if you are going to steer the water with a paddle, a vigorous steering with a paddle, there's an increase in temperature of the water because you're actually applying work to the water. So the result is heat. Okay? So muna yung discover in his experiment. Okay? And then he found out that the increase in temperature of the water is directly proportional to the amount of work done by the paddle. Okay? So, na-experiment gihimo si Joule, and then he discovered that the relationship of temperature and work done is directly proportional. Okay. So one good example of heat to work is this. Okay. Heat from the flame provides energy to do work. So if you're going to boil a water, so what will happen to the water? Diba it will rise. So there is a displacement from its initial position to its final position. So nisaka siya. So therefore, work is done using heat. Okay. Another one, we have work to heat. Okay, work done by a person is converted to heat energy via friction. So if you're going to rotate this, so this is mechanical work done here. And then what will happen in this portion? Diba, there's friction and it can produce heat. Just like when you rub your hands together, diba, it can produce heat. Okay, that is work to heat. So the conversion of work to heat is reversible. So that is the mechanical work can be transformed to heat, and then heat can also be changed to work. Okay, these reversible equivalents may be expressed in this equation. So we call that the mechanical equivalent of heat. Okay, so the reversible equivalents may be expressed as W is equal to J times Q. So what is J? Okay, that is what we call as the mechanical equivalent of heat. Okay, that is constant, don't worry. Constant ang value ni J. And then W there is work done to produce heat. Q is the amount of heat produced. And then our J, we call that the constant value of the mechanical equivalent of heat. So it was James Prescott Joule who discovered this value. Okay, through series of experiments. Okay, the constant value of J was determined by James Prescott Joule through series of experiment, and that is constant. J is equal to 4.19 joule per cal. Okay, which means to say that 4.19 joule of work can produce, okay, 1 calorie of heat. And then reverse. 1 calorie of heat can do 4.19 joule of work. Okay, that is the concept behind the mechanical equivalent of heat. Okay, so again, 4.19 joule can produce 1 calorie of heat, and then 1 calorie of heat can do 4.19 joule. So it's like the equivalence of 1 calorie is equivalent to 4.19 joule. So later, I'll show a problem in which you will convert calorie to joule. Okay? So that's the purpose of the mechanical equivalent of heat. So this is used to convert calorie to joule or joule to calorie. Okay? So don't forget, 1 calorie is equal to 4.19 joule, and then 1 kcal is equivalent to 1,000 cal. Okay? Mo ni siya ang mga conversion factor for the this one is for the mechanical equivalent of heat. Okay, so let's proceed to sample problem number 1. So I want you to do this in your notebook. How many joules of work can be obtained from 1.00 times 10 to the power of 4 calories? Okay, so you are asked to solve for work. Okay, and then the given in this problem is only calorie. Unsa galing ning calorie? This is what? Work, heat, or energy. Sasa ni siya na unit ang calorie? Kindly use your microphone.
Heat.
Okay, so this is our heat. Value is 1 times 10 to the power of 4 calorie. So we have one given. Ang Q ang given diri. Mao ni siya. So inyong goal is to solve for work. So unsa man inyong gamito na formula?
Work is equal to JQ.
Okay, work is equal to J times Q. Since J is constant, and that is the mechanical equivalent of heat. Now, what is your answer?
41,900.
Okay, that is correct. So, sa'yo na kayo siya na problem. You just convert calories to joule using the mechanical equivalent of heat. Okay. So, ang given here is only Q. That's heat. So 1.00 or 1 times 10 to the power of 4 calorie. And then find or required is the work done. So solution, you just use the W is equal to J times Q. J is constant, 4.19 joule per cal. And then our Q is 1.00 times 10 to the power of 4 cal. So the answer is, pila to? 41,900, right? So cancel out calorie and then joules. Or pwede siya in scientific notation, 4.19 times 10 to the power of 4 joules. Okay? Parehara na siya. This one is in decimal and this one is in scientific notation. Kay 4 man ka, move going to the left. Okay? So that's why times 10 to the power of 4. Am I clear, 9H? Yes or no? Hello? Hello?
Yes, sir.
Okay. So kindly screenshot for reference. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Again ha, don't forget the value of the mechanical equivalent of heat. 4.19 joule per cal. That's J. Okay, next, let's try sample problem number 2. Okay, for sample number 2, this is the problem. How much heat energy is required to raise the temperature of 754 grams of aluminum from 20 degrees Celsius to 80 degrees Celsius, given that the specific heat of aluminum is 9.10 times 10 to the power of 2 joule per kilogram Kelvin. Okay, so for this example, you're asked to solve for unsa? Sa pangitaon.
Hit.
Okay, heat. How much heat man? So Q ang unknown here. And then what are the given? Kindly use your mic. Sige, you cite one given for this problem.
Mass 754 grams.
Okay, you have mass 754 grams. What else?
C
Okay,
9
specific
point
heat. That specific heat of aluminum is 9.10 times 10 to the power of 2 joule kilogram Kelvin. What else? Napa, dua.
final temperature of the initial temperature.
Okay, what is the initial temperature there? TI. From, kanang na from.
20 degrees Celsius.
Okay, 20 degrees Celsius. And then, T final is 80 degrees Celsius. So, you need to find Q. So, what is the formula to solve for Q? Mm-hmm.
MC delta T.
Okay, solution. Q is equal to MC delta T. Okay, so M is, by the way, you notice na lahi ilahang units, right? You have grams, but then the specific heat is in joule, kilogram, Kelvin. So i-adjust na to siya. Kailangan same sila og units for mass and unit for temperature. So we will convert 754 grams to kilograms. So what is the conversion? Divide lang siya sa 1,000. 754 divide by 1,000 para may mo siyang kilogram. Sige, what's your answer?
0.754. 754.
0.754. Okay, correct. 0.754 kilogram. Okay, again ha, basin ni mga tanang ano na 0.754. Gi-divide lang nato siya sa 1,000, ang 754. Conversion of grams to kilograms. Okay, next, what about for initial temperature from degrees Celsius to Kelvin? Saan galing to pag-convert degrees Celsius to Kelvin? You just add, what is the value? I hope you still remember that. Para may mo siyang Kelvin. Pila ang i-add sa degrees Celsius? 273, right? Again, degrees Celsius to Kelvin, add 273. Di ba 273.15 man na siya? But we'll just use 273. So 20 plus 273, pila?
293.
20 plus 273. Para i-Kelvin naman nato siya.
293.
Okay, 293. 293 Kelvin. What about 80 plus 273?
353.
300? Pila?
353.
353 Kelvin. Okay. Remember, delta T is just final minus initial. Okay? So, i-subtract lang dayon. Diba? Delta T is equal to TF minus TI. Sige, i-minus na daan para dili na nako siya isulatas. So, 353 minus 293. Para mauna natong delta T. Pila?
60.
60? Okay, so our delta T is 60 Kelvin. So, muna na siya, 80 minus 20 raman na siya. Sure, 60 raman. Our goal is ang Kelvin manggod. Okay, dili degrees Celsius. So, ato agad siyang i-convert to Kelvin. Okay, so pwede na nato ma-cancel out ang Kelvin sa specific heat and also for the kilogram. Okay, same naman sila. Okay, so substitute all the values for mass, 0.754. Specific heat is 9.10 times 10 to the power of 2. Joule, kilogram, Kelvin. So, ubos na lang na ako isumpay ha. And then, our delta T is 60 Kelvin. Okay, multiply everything. Then, what is your final answer?
41,168.4 joules over
Okay.
kilogram Kelvin.
Okay, 41,168.4. Pila ang unit? Ayun sa ang unit, I mean, for heat. Cancel out man ang Kelvin. Cancel out ang kilogram. So, the remaining unit is? Hello? Unit of heat.
Joules.
Okay, joules. So, this will be our final answer. 41,168.4. You can answer it in scientific notation, 4.12 times 10 to the power of, pila na ka move? 1, 2, 3, 4. Okay, 4 joule. Pero pwede rin siya 41,168.4. But if you want it in scientific notation, then 4.12 times 10 to the power of 4. At to 2 decimal places man rounded off. Okay? So question for sample problem number 2, you can screenshot. Hello? Okay. Let's proceed. Sample problem number 3. A simple demonstration of how work can be transformed into heat is the rubbing of hands together to warm them up. Suppose that you are rubbing your hands, you perform 4,500 joules of work against friction. A, how much heat in calories did you generate? So, for letter A, you will solve for heat in calories, not in joules, but in calories. And then B, by how much did the temperature of your hands change? Okay, assume that your two hands have combined mass of 1.50 kilogram and that the specific heat of the hands is 0.83 calorie per grams degree Celsius. Sige daw be, you try this in your notebook. Sige, everybody, try this. What formula you will use for letter A? Hello? NH? Anyone? So these are the given.
Work equals JQ.
Okay, work is equal to JQ, correct. So this is the work. Here's the pen. So this is work, 4,500. Ako lang ika ng given ha. This is the mass. And this is the specific heat. So for letter A, you just use this equation of work is equal to JQ. So you need to solve for Q man, di ba? How much heat in calories. So work is given. So i-rearrange na nato siya. Pwede ra na siya. Q is equal to work divided by J. Since work is given, that is 4,500 divide by constant 4.19 joule per cal. Okay, what is your answer?
1073.99 calories.
Sawi. 1,007
73.
73. Wait lang, I verify sana ako. 45, 4.19. Okay. I-round up siya. 74 na siya. Miles, hello?
Yes, Jen.
Okay. I-round up lang siya ha. Whole number. So, 1,074. So, this is in calories. Okay. So, we have now answer for letter A. 1,074 calories. Cancel out J man here. Okay, next for letter B. By how much did the temperature of your hands change? So you need to solve for delta T. So you use the Q is equal to MC delta T. Change in temperature inyong pangitaon. Sige. Can I erase this for letter A? Okay na for A. Hello? Hello?
Yes,
Okay,
sir.
pata. Okay, erase na ako ni ha. Anyway, dali naman ang A. For letter B, you will solve for change in temperature. So that is delta T. So you just rearrange the equation of Q is equal to MC delta T. So just divide both sides by MC para delta T na lang mabilin. Okay? Cancel, cancel. So use this equation. Delta T is equal to Q divide by MC. So we have now the value of Q, right? Pila gani ang value sa Q? I-solve na to for A.
1074.
Okay, 1,074 cal. And then divide that to our mass, 1.50 kilogram. And then our specific heat is 0. Okay. Nakakuan pa man din ni siya. Naka-kilogram. So, we need to convert that to grams. Okay, para ma-cancel out siya. So, pila man? 1.50, 2 kilogram.
1,500 grams.
Okay. Yun sa man mo miles. Multiply by?
1,000
Okay. Times lang sa 1,000. So, may mo siyang 1,500 grams.
grams.
Okay. For a while lang ha, let me erase. Okay. Careful mo ha sa unit. Kailangan mag-same gina sila. So, 0.83 cal degrees Celsius. Okay, what is your final answer? 1,074 divided by 1.50 times 0.83.
0.86 Celsius.
0.80
6 Celsius.
What? Sorry, wala pa din ako siya na change to 1,500. Anong grams ra akong gibutang? Wait lang ah. 1,500. Okay, so again, 1,074 divided by 1,500 times 0.83. So our answer is 0.86
86 Celsius.
degrees Celsius. Okay. Cancel out calorie, cancel out grams. So the remaining unit is degree Celsius. So our change in temperature is 0.86 degrees Celsius. Okay, that is our final answer. So kindly screenshot 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Okay, time check. It's already 1:07. So this will serve as your assignment. Practice exercise 18.1. So you do this in your notebook and we are going to discuss the answer next meeting. Okay, tomorrow. Yes, tomorrow. So this time, let's proceed to our next activity. This will be done by group. You're going to make Venn diagram. Okay. So kindly take note of your assignment, practice exercise 18.1, page 422. Okay, check-up time using a Venn diagram, compare and contrast work and heat. Okay. I think you're familiar with Venn diagram. So you just compare and contrast the similarities and difference of work and heat. Okay. So I'll group you into 5 groups para dali. Any question, by the way? Steam engines or mga engines, Lawrence. Itong boiling of water, steam. So that is from heat to work. If you're familiar with locomotive trains, kana bitong gaaso-aso na train, that is a good example of heat to work. They are using coals para mo-move tong ligid. Okay. Anyway, we will talk about that under heat engine. Okay. Sige. O sa mong i-group. Breakout rooms. Five groups. Who is absent? Wala. Di lagi siya equal mo. Decipher and uy, dagana eh. Di siya equally mo. For groups na lang na ako. Okay, group 1, Gab, Janessa, Nor, Sofia. Group 2, Judy, Lawrence, Rupert, Marinel. Group 3, Ira, Jade, Miles, Pauline. And group 4, Angel, Candy, Ian, and Iza. Sige, you discuss. You may use the, saan yung gusto gamiton for Venn diagram? Canva? Favorite? Ginanin yung Canva. Sige, go. Join na.
Ako template. Work. Usa to siya, heat and work lang. Okay. Heat. Wait. Wait lang. Lang. Wait lang guys. Ikaw lang. Guys, nag-share kung Canva dara na lang ninyo i-type atong answers. Ayun na i-mine ng Nebula kaysa ever older na siya na template.
Siya mag-sub, Lawrence. Yes. Isa lang. Abi substitute teacher. Okay, isa lang ang mag-submit. But don't forget to include your members ha. Basta na malimtan. Okay. So deadline for Venn diagram will be tomorrow, 11:59 p.m. And in your notebook ha, i-answer tong problem solving for page 422. So any question about our lesson this afternoon? 9H? 9H.
None.
None, sir.
Okay, let's have our closing prayer. Sophia?
Let us put ourselves in the holy presence of the Lord. For the Catholics, please make the sign of the cross in the name of the Father, the Son, and the Holy Spirit. Amen. Dear God, thank you for this session we had in Science A today. And please guide us in our next class and guide Teacher Maita in her next class as well. This we pray. Amen.
Okay, that's all for this afternoon. Goodbye and thank you.